Welcome to the next session of the grade 10 maths. I believe we've got three core sessions or sections of work. There's algebra, there's geometry, which you've both covered so far, and then there's trigonometry. Okay, now trigonometry brings actually algebra, shapes, and geometry, shapes, to algebra, which is solving for x's, etc. Okay, now a lot of people view trigonometry as a very difficult section of the work. In essence, all it is at this stage is just a right angle triangle and some definitions, right? The definition is, if I tell you that this is an apple, you believe me because I say it's an apple. Okay, well, not really, but essentially we're going to make some definitions regarding angles. This is all about angles. Okay, so let's just start off by drawing something very simple. All right, okay, it would help if I do that, and there we go. Okay, there's a right angle triangle, and let me call it ABC. All right, so far so good. Right, I'm going to call this angle here unknown theta. Okay, it could be x, it could be theta, it could be alpha, it can be beta, it can be gamma, it can be anything you like. It's just an angle. That's all it is, right? And if you remember, okay, how did we get hold of the angles? We used one of these, didn't we? Okay, let me just we used a protractor, right? Do you remember way back, holding it forward? We measured the angles on a protractor like that, didn't we? Right? From a point we measured, we bisected angles, and we did all sorts of things with compasses, etc. So it's just an angle that you measure, and we measure the angle in degrees. Right? And how many degrees in a full circle? In a full circle is 360 degrees. Okay, so we say, right, if I measure from here and I go all the way and I measure 360, I have done a full circle, haven't I? That's a dreadful circle, I know. Right, now let's get back to our triangle after we've digressed a little there. Now, this is the key here. Stand inside this angle, right, and look out. What do we see? We see on this side the opposite, okay? Which means if that's opposite, the one next to me, we call the adjacent. Okay? Opposite and adjacent. Important to find these, right? When you found them, you use a pencil and you label them, right? The last one, we're going to call you know this one, hypotenuse. Don't write it out. How do we abbreviate these? Oh, well, we go opposite, A and H. You can use O's, big A's, whatever you like. It doesn't matter. I prefer the small and the H. Doesn't matter. So let's just make you a small h over here. Right. Now, we've done a little bit of a definition here. Now, we said, okay, we know what the opposite is. So if we look at a triangle, let's draw a triangle now. Okay. Let's just draw a triangle, and I'm going to just draw it this way for a change, all right? And I am going to say, there's my 90. Let's say theta is up here, all right? Where is opposite? What do? I stand in the angle, right? Like that, and I look out. Here's the two pieces on either side of me. The one there is my opposite. So it's there, which means my adjacent is next to me. Why? Because H is always the longest side. You can start with identifying H if you like. It's the one opposite the 90 degree, or it's the longest side. So start with H if you like, but always find them. Okay? It makes it a lot easier. Now, if you've ever looked on your calculator, right, which I'm sure you have, because those of us in maths and that, we're quite curious. You've seen things like these words here. Okay? Now, it's a definition. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. Can you see that we've used all three combinations of lengths? This is the length. Okay, let me just specify. The length. So when we're looking at a triangle, let us have a look at a triangle that we all know. Okay, 3, 4, 5, and let's put theta over there. So what did I say? We say, okay, let's find opposite, hypotenuse, and adjacent. Just, okay, hypotenuse. Sometimes it does that. Hypotenuse, opposite, adjacent, and hypotenuse. Well, now we say to ourselves, okay, cool. Then what is sine alpha? Well, let's look at it here. Sine of, sorry, I've got theta. Sine of theta is equal to, opposite is 3 over 5. Cos of theta is adjacent over hypotenuse, 4 over 5. And lastly, tan of theta is opposite over adjacent. Right? Now, the way triangles are constructed means that sine theta, cos theta, and tan theta are unique for any single angle that you've got on the protractor here. Right? Any angle on here has got a unique value of sine theta, cos theta, and tan theta. Why? Let's just have a look at this. Okay? For those of you who do EGD, okay, this is obviously pretty straightforward. But now if you look at this, this is a 30, 60, 90 triangle, right? This one is a 45, 45, 90 triangle, right? Can you see that in this triangle, if I make that a little bit longer, the hypotenuse, okay, I change the ratio of the lengths of my triangle. So it means that for every angle, you've got 3 unique ratios of the lengths of the sides. Okay? We've got the unique ratios. So let us say, for example, we're just going to use a calculator now, just for a few moments. Okay? Let's look at this. Find the following. Sine of 45 plus cos of 30 degrees. And they say, find that to, and they will tell you how many decimal places. What do we do? Okay. This is where you use the calculator, right? You will push sine, and you will see it will give you a sign. It will open a bracket. Okay. It will do this for you. You put in your angle, 45, and close the bracket. Right? Plus cos, okay, and it will do that, fill it in, and close the bracket. 30, close the bracket, and press equals, and it could give you this, root 3 plus root 2 over 2. Don't worry about those, okay, we're going to get to those. But what do I do now? Well, you press SD and it gives you 1.5731, and if you only wanted to 2, it's 1.57, which means you would have looked at the third one and moved it accordingly, right? Or rounded off accordingly. All right? Now, let's just look at a couple more, just as we can go through this. Let's look at 2 sine 60, okay, minus 3 over 2 cos 45 degrees. Now, if you want to do it like this, you could say, right, that is 2 times what? And let's look up sine 60 first. Okay, that is root 3 over 2, and I press SD, 0.866. Okay, minus 3 over 2 times cos 45. And we say that is 0.707. Okay, like that. Then we calculate these out normally. Okay, and the answer we're going to get for that is going to be 0.6714. Okay, 0.6714. Because we'd multiply that by 2 and that by 3 over 2 and then subtract them. Okay, that's your basic calculator moves that you should know how to do at this stage. What if we've got this then? Sine of 2 times 20 degrees plus tan of 3 times 40 degrees. Can you see the 2 is now on the inside? That means that it's 2 times 20. So this is actually sine of 40 degrees plus tan of 120 degrees. Now you can see we're moving out of the 0 to 90. Why? Well, because we can get 120 degrees. It just goes a bit further around, doesn't it? Okay. Then we would look up that and we'd say that is the sine of 40 degrees. So we'd look it up. Sine of 40 is 0.6428 plus tan of 120. Tan of 120 is equal to minus 1.7321. Can you see the moment I got a minus sign, I put in brackets? Why? Because I know there's a 1 out there and I must multiply it in. And I end up with minus 1.089. All right? Let's have a look at this now. 3 times sine of squared of 25 degrees minus 2 cos squared 40 degrees. How do we deal with this? Let's have a look at this on its own. Sine squared of theta. Okay. Now, this is something you've got to remember, and what you do is you straight away we change the sine squared until you get stronger at it. That is what? The definition of something squared is something times itself. This is sine theta times sine theta. All right? So that is 3 times sine of 25 degrees times sine of 25 degrees. It is not 25 degrees squared. Otherwise, I would have written it as sine of theta squared. Can you see that the 2 there is not equal to sine squared theta? Because sine squared theta is sine theta times sine theta. Okay? Right. Let's move on a little bit, shall we? Well, then we would do the same on the other side. I just haven't got space there. 2 times cos of 40 degrees times cos of 40 degrees. You can choose. I personally always prefer brackets. I really do. And that comes to 0.5358. Let me just check again. It's cos of 40 equals that. Then I square it, is that, times, where are we? Sine of 25, sorry, my bad. Sine 25 equals that, x squared equals that, and then times by 3 is 0.5358 minus 1.1736, okay, and equals 0.6378. And they said to 2 decimal places, which means I look to the third and it's greater than 5, so therefore 0.64. Okay, 5 or greater, round up, correct? Okay, now what is the next step with trigonometry? Well, this. Let's have a look. They say this. What is tan of 30 degrees plus 20 degrees? Okay, and let's say we're going to square it and we minus 1 over there. Okay, well, what do? First of all, that's brackets there. It's actually tan squared of 50 degrees minus 1, right? How do I rewrite that tan squared? That's tan of 50 degrees, okay, all squared, or minus 1, or I could have said that is tan of 50 degrees times tan of 50 degrees, correct? Minus 1, okay? You can develop your own shorthand for that, okay? Now, I would say, right, what is tan of 50 degrees? Tan of 50 equals that. Then I must square it. X squared equals that. Then I must minus 1 from it. Gives me 0.4203, which is to 2.42, right? Now, that's great. So the calculator does this for us. And you don't need to know, or you don't have to know at this stage how it does it, okay? If you're in AP Maths later on in the grades, we might get to how the calculator does it, all right? Although I think it's pretty much, yeah, it might be there a little bit. Right, what do we do now? But now, hang on. That was straightforward. Let's just look. We said here, tan of 45 equals what? You said, in your calculator, tan, open brackets, you put in the 45, and you pressed equals, right? We said tan 45, close brackets, equals 1. Now, what is the opposite? What's the opposite of that? What if I said to you tan of theta equals 1? Can you see what I've done? I've now given you this and asked you to find theta. All right? This is the opposite way around. Well, essentially what we're going to do here is we're going to take, I think I'll keep it in red. Okay? I'm going to take, on this side, I've got tan of theta, which is my angle, equal to 1. I want to take the tan, let me just put this in blue. I want to get the tan to the other side. Why? Because all I'm looking for is the angle, aren't I? How do I get the tan to the other side? Well, some people say, okay, tan of theta, then I'm going to divide that by tan equals 1 over tan. Then the tan cancels out and theta, but hold on. If you put into your calculator, try it, okay? 1 divide tan. You get this. 1 divide by, and then it opens a bracket. If you put equals, it's going to give you syntax error. Okay? Because you haven't filled in the bracket. Why? Because tan, cos, and sine always go with an angle. Okay? Like this. Remember where they come from. Guys, it's not very difficult. Okay? Here they are, here. Sine of an angle, theta, theta, and theta, they all go together. So it's tan of an angle, sine of an angle, cos of an angle, which means no, you cannot divide through by tan on its own because tan doesn't exist on its own. It means nothing. Try going and saying, okay, 1 divide cos equals syntax, right? 1 divide by sine equals syntax error. It means you cannot divide by the letters cos, sine, or tan. It's not possible. It doesn't exist, okay? So the opposite, we need to find the opposite because theta and what we call it is this. Tan to the minus 1, which is arctan, okay? That's the terminology I grew up with. What have we done? We have said tan of theta equals 1. We have then said tan to the minus 1 of tan theta equals tan to the minus 1 of 1. Can you see over here? I hope I'm not complicating it. These two are cancelling out. Please, not dividing, not that. It's the opposite function. What have we done here is the same as this. All right? It's the same as if I told you that x squared is equal to 9. You want to get rid of the square. What is the opposite function to squaring? Is square root both sides. That's what I've done. The tan was like the square. I've done the opposite. This is the opposite function. Okay? The opposite operator. Okay? The same applies here. If I had the cube root of x cubed is equal to 27. Therefore, that cancels out, doesn't it? The tan to the minus 1 is cancelling out that tan. Remember, you can never divide through. Okay? Well, let's have a look here. Okay? Let's say, all right, let's say cos of x equals a half. All right? And we say, right, therefore, I must take the opposite of cos. To give me x is going to be cos to the minus 1 of a half. Please don't skip steps here. It goes wrong if you do. Therefore, x equals, now how do we find these? Look on your calculator above sine, cos, and tan. You will see the sine to the minus 1, cos to the minus 1, tan to the minus 1. So what will you do? Shift sine or shift cos, 0.5 and equals 60 degrees. Remember, the answer will be in degrees. Let's do this one. Sine of alpha is equal to 0.35. Therefore, alpha must be equal to, the opposite of that is sine to the minus 1, 0.35. So alpha is going to be equal to, and we're going to go here, it's this arc sine, opposite is the sine, shift sine, 0.35 equals 20.48. Okay, 20.49 degrees actually. Let's look at this one again now. All right, let's say we've got cos, no, let's do a tan, shall we? Let's do tan. Tan of beta is equal to 0.7. Therefore, beta is equal to arctan of 0.7. All right, and what are we going to do? We're going to look it up. We go shift tan 0.7 equals 34.99. Okay, which you'd actually round to 35 degrees, right? Okay. That is how we're going to deal with these. So there's a whole bunch of things that are coming, okay?